So the last half of this lecture will pick up at section 5-4 with the dermis. So the dermis lies between or beneath, the epidermis and has two major components, a superficial papillary layer and a deeper reticular layer. The papillary layer consists of areolar tissue that supports and nourishes the epidermis. It contains capillaries for blood supply, lymphatic drainage, and nerve fibers. The deeper reticular layer consists of an interwoven meshwork of connective tissue. Elastin and collagen fibers are present and they blend into the papillary layer. The dermis also contains the mixed cell populations of connective tissue proper. It also has accessory organs like hair follicles and sweat glands. The hypodermis is not part of the integumentary system technically. However, the dermis is attached to this extensive network of connective tissue fibers, and it's important in the stabilizing and the position of the skin relative to the underlying tissue. So the hypodermis consists of areolar tissue with many fat cells. Also, the blood supply to the skin arises from a network of blood vessels called the cutaneous plexus in the hypodermis at its border with the reticular layer of the dermis. So take a moment and see if you could briefly describe the location of the dermis. We'll turn our discussion to the accessory organs now, starting with the hair. Hairs are non-living structures produced in little organs called hair follicles, which are epidermal invaginations into the dermis. Epithelium at the base of the follicle caps over the hair papillae, connective tissue that connects the capillaries and the nerves. Epithelial stem cells divide to form hair matrix surrounding the papilla. As the hair matrix grows, making the hair longer, and cells become keratinized and die, halfway to the skin surface it becomes the hair root. And above the surface, it's called the hair shaft. So the shaft has three layers of dead cells. From outer to inner, they are the cuticle, cortex, and the medulla. So the hair has a number of very important functions. It protects the scalp. It prevents the entry of foreign particles into the nose, eyes, and ears. It prevents injury via sensory perception, and it expresses emotional state. For example, your hair standing up due to contraction of the erector pili muscles. The hair color differences are due to the type and amount of melanin from melanocytes. And aging can result in less pigment production, causing the hair to grow gray or white. Now you may have noticed on the drawing of the hair the accessory sebaceous gland. So sebaceous glands secrete sebum into the hair follicle through holocrine secretion, so rupture and cell death. And the sebum is a liquid that is lipid rich. It's an oil. It lubricates the hair and the skin, and it actually inhibits the growth of bacteria. Similarly, sebaceous follicles secrete sebum directly onto the skin of the face, back, chest, nipples, and external genitalia. Sebaceous glands are sensitive to hormonal changes, and inflamed glands can result in acne. Another exocrine gland of the skin is the sweat glands, also known as sudoriferous glands. They include two different types, the apocrine and the merocrine. Apocrine sweat glands are actually misnamed. They rely on merocrine secretion methods, so they're secreting vesicles from the Golgi body. And they secrete a sticky, cloudy sweat onto hair follicles in the armpits, around nipples, and in the pubic region. These sweat glands become active at puberty. Now, this sweat can serve as a food source for bacteria on the skin, which can increase the odor. Deodorants and antiperspirants contain an astringent compound that contract the skin and its sweat glands openings. Merocrine sweat glands are also called eccrine sweat glands, and they're coiled tubular structures that secrete a watery perspiration directly onto the surface of the skin. They're very numerous all over the skin, but there are many on the soles of the feet and the palms of the hands. Though the sweat is mostly water, it contains electrolytes like sodium and chloride, urea, and organic nutrients. Its main function is to cool the body through evaporation. Nails, another accessory structure, protect the tips of fingers and toes from distortion, especially when they're subjected to mechanical stress, like running or grasping an object. So the visible nail body is made of dense keratinized cells that are recessed under the surrounding epithelium. The nail bed, deeper level of the epithelium, is covered by the nail body. And the nail root is where the nail is produced. It's typically covered by the cuticle. The lunula is a pale crescent near the root of the nail. So we're at another checkpoint, and you can pause the lecture recording here and describe the typical strand of hair. What are the functions of sebaceous secretions? Where does nail growth actually occur? This next section looks at the repair of the integument and is the conclusion of Chapter 5. So skin regeneration occurs because stem cells of the epithelium and the connective tissue undergo cell division. And this will replace lost or damaged tissue. There are 4 steps of skin repair. First, there is the scab formation, where a blood clot will form on the surface. And this is a temporary patch. And the idea is it can help prevent additional microbes from invading the injury. Then you have granulation tissue as the next step. Granulation tissue is formed from the combination of the fibrin blood clot, fibroblasts, and capillaries. Typically, you're going to have macrophages coming in to clean up debris. Clot removal and the decline of capillaries is the next step when you have a scar that's formed from the remaining meshwork of collagen fibers. And the degree of scar development is dependent on the severity and the location of the injury and the age of the patient. Sometimes you can even have keloid scars, which are thicker, raised, smooth, and shiny epidermal surfaces. The effects of burns can be caused by a number of different sources, such as chemicals, heat, radiation, or even electric shock. And the effect and the severity depends on the depth into the tissues and the total area that is actually affected by the burn. And this table outlines some of the common classifications of burns. For example, the difference between a first degree and a third degree is how much and which cells are killed. So a first degree burn, you'll have superficial cells of the epidermis that are killed, possibly injuring deeper layers of the epidermis. Whereas if you compare that to a third degree burn, you've killed all epidermal and dermal cells, and you may have even injured the hypodermis in deeper tissues and organs. So you can see that there's quite a bit of difference there. And so it depends on which cells, how deep, and how many of them are affected. And so this last checkpoint asks you to describe the combination of fibrin clots, fibroblasts, and the extensive network of capillaries and healing tissue. Do you know what term describes that? Go ahead and use that as an opportunity for self-assessment, and that will conclude the Learning Plan 2 chapters.